Hello viewers, welcome back to the course on scientific computing using Matlab. So, we will continue with the concept that is called the interpolation. So, let us continue with this one. So, in the previous lecture we have discussed, we started with the interpolation, and then we have discussed the various operator, that is forward operator, the backward operator, central difference operator, the mu, that is the average operator, and this is a shift operator. So, these are all the difference operator, and then we have also discussed the differential operator, that is D. Now, we can use this. So, I want to discuss the repeated use of application and exponential of operators. So, this is so what is the meaning of repeated applications? It means that suppose I want to apply forward operator 2 times on the given function f x. So, this one I will applying the 2 times. So, I can write this function as operator as del square f x. So, in this case we are repeating this process 2 times. So, let us see what will happen. Now, suppose I want to apply this. So, del of f x. So, del of f x, I know that it will go f x plus h minus f x. So, I am applying at any x. So, it will move further by the step h. So, I have the data, that is data is given to me. So, this is my x 0, suppose x 1, x 2, x n. So, I am applying this operator on any x. So, it will go further by the distance h, and this will be x 3 and minus f x. So, this will be the difference operator, and now again applying this one. So, this will be x plus h minus del f x. So, from here this is equal to f x plus 2 h minus f x plus h. So, it will go further. So, it will become 2 h minus, and this will be f x plus h minus f x. Now, from here I can say that f x plus 2 h minus 2 times f of x plus h. So, it will be minus minus plus f x. So, in this case you can see that when we apply this forward operator 2 times, then the value of the function is involved at 3 points. So, in this case if I know the value of the function at x 3, x 2, x 1, only then I can take the second forward operator at the value x 2, because in this case I have to go further, not at only x 3, even x 4 also, because in this case wherever the value I am considering applying the operator, suppose I am applying here. So, I have to go 2 steps further. So, I will go from here to here. So, 2 steps further and then 1 step and that value of the function. So, in this case I am applying the forward operator 2 times. So, I need the value of the function at 2 places after that. So, this is the forward operator, 2 times I am applying the forward operator. Similarly, I can apply the 2 times backward operator like this one. So, in this case you will see that in that case I need the value of the function, 2 value of the function before the value of the given function value, before the value f x. So, in this case I need to go backward at this place and this place to find the value of the functions using the 2 times backward operator. So, based on this one I can apply n times forward operator or n times backward operators, or I can apply n times central difference operator. So, this way we can apply the any number of times the same operator we can apply on the given function. Now, I want to apply I want to use the shift operator. So, shift operator, I know that this is represented by E. Now, what is the meaning of E? So, suppose I take the e raised to power p and applying on the function f x. So, this will be equal to value of the function x at ph. So, I am doing this, that I am shifting the function by ph, because it is the e raised to power p. So, p is any real number. So, it can be any real number. For example, if I put p is equal to 1 and this is f x, so in that case my function value will be x plus h. It means that I have the value of the given data and I am applying the shift operator, suppose at here, then the value of the shift operator will be this value, 1 forward. Now, suppose I want to apply e half f x. So, this will be value of the function at f plus h by 2. So, now here the h by 2 is here, this value. So, now if I apply the operator e raised to power half on at this value, then I will get the value of the function at this point. Similarly, I can define my value e minus 1 by 2 f x. So, that will be e x minus h by 2. So, it is going to be 1/2 steps backward to that value. So, this way we can define, even I can define e minus 3 by 2 f x. So, it will be f x minus 3 by 2 h. So, this way we can move with the shift operator for either forward direction or in the backward direction. Now, we want to find the relations. So, I can define the another one, the interrelation between operators. So, what is the relation between the forward operator or the backward operator or the shift operator? So, that we want to see. So, this is the interrelations between operators. So, suppose I want to discuss the first one. I know that if I applied the forward operator to the function at x, then it will be f x plus h minus f x, and this one I can write as, so this is the f x, so I can write as the e of f x minus f x, because e of x I know that if I apply this one I will get the value at the next step, that is x plus h. From here I can take f x common and its value will be this one. So, based on this one I can say that the forward operator is always equal to e minus 1, and from here I can apply this here also. So, e will be 1 plus forward operator. So, that is the relation between the shift operator and the forward operator. The second one is that I know the nebula, the backward operator on the f x. So, this one I can write as f x minus f x minus h, and this one I can write as a f x minus e minus 1 f x. So, in this case I am taking the e raised to power minus 1, because I am going backward, one step backward, and from here I can write e 1 minus e inverse f x. So, from here I can say that this nebula will be equal to 1 minus e inverse, and based on this one I can write that e, this will be equal to 1 minus nebula, or from here I can write that the e will be equal to 1 minus nebula inverse. So, that is the relation between the shift operator and the backward. This is the shift operator and the forward. Now, I can find the another relation. So, the third relation I want to define for this one. I know that the central difference delta f x So, this is equal to f of x plus h by 2 minus f of x minus h by 2. So, it is going half forward and half backward, and this is the value of the function f x. And this one I can write as e half f x minus e minus half f x. So, from here I can take e half minus e minus half f x, and from here I can say that this gives me the delta is equal to e half minus e minus half, and that is the relation between the central operator and the shift operator. Similarly, I can define the next one is the fourth one. So, the fourth one is I want to define the relation. I know that using Taylor expansion, I can define, I want to find what is the f x plus h, and I apply the Taylor expansion. So, this will equal to f x plus h f dash x plus h square by 2 factorial f double dash x and so on up to h n by n factorial f n derivative and so on. So, this is my Taylor expansion about x. So, from here I can say that I can write this as a f x plus h, and this one can be written as d of f x, because in this case the function I am considering is differentiable, well defined and differentiable. It has a infinite number of time differentiable function, because I am able to get the differentiation. So, I can apply the differential operator on this one. Then I can write h square by 2 factorial d square f x, and this can be h n by n factorial d n f x and so on. So, from here I can write as, so I can take my function f x. So, from here I can write this as 1 plus h d plus h d square by 2 factorial h d cube by 3 factorial and so on. So, this one I can apply and f x. So, this is applying this operator applying on the function f x, and on the left hand side this is equal to e of f x. Now, from here I can write that e of f x is equal to, and what is this? It is the exponential h d. So, it is a series of exponential series, and I can put e to the power h d f x. So, that is giving me that e should be equal to e of h d. So, shift operator is equal to exponential h d, or I can say that this is also equal to h d is equal to log e. So, that gives me the relation between the e and the h d. So, that is the another relation we have. Now, so that is a very important relation we should always keep in mind. So, this way we can define many relations. So, but here we are doing only few relations. Now, we will discuss the another thing, the application of operators on some functions. So, let us see that how we can apply the operators on some function. So, I will start with the very simple function. So, let my function f x is equal to some constant c. So, I want to apply the constant, just take the constant function and I want to apply this operator. So, let us apply my operator, forward operator. What will be the f x? I know that the forward operator applying on the f x will be equal to f x plus h minus f x. Now, the value of the function is constant, so it will be c minus c, that is 0. So, from here I can say that f of f x will be 0. Similarly, if I apply the backward, that will be also 0. Similarly, if I apply the central, then that will be also 0. So, from here I can say that if I take a constant function and apply my difference operator on that one, forward, backward, or this one, so then the value will be 0. So, it is same as the derivatives. If you take the derivative of a constant function, that is value is 0. So, this is the constant function. So, let us take the another one, the next function. If I take f x is equal to some linear function a x. So, it is a linear function. So, let us see what will happen. Now, I suppose I apply the forward operator. So, it will be f x plus h minus f x, and that will be a x plus h minus a x, and that gives me a h. So, it is a constant value, because h is constant and a is constant. So, if I take the one differential operator on this, I will get a h. Now, suppose I want to apply one more time this forward operator. So, this is the constant function, so value will be 0, as we have done in the previous one. So, from here I can say that if I have a linear function and if I apply the 2 times forward operator, its value will be 0. If I apply 1 time forward operator, its value will be constant, and that will be a h. Similarly, I can find the backward operator f x. So, that will be again, this will be f x minus f x minus h. So, it will be a x minus a x minus h, and this will be a x minus a x plus a h. So, this will again the same value a h, and if I apply the 2 times the backward operator, its value will be 0. So, from here we are able to understand that if my function is a linear function, I can apply any operator only one time. So, if I apply the operator one time, its value will be constant, and 2 times its value will be 0. Third one, suppose I take the function f x is equal to some quadratic. So, that is I take x square. So, it is a quadratic function, or I can take a x square. So, in this case I just want to apply my forward operator. So, the forward operator in this case will be f x, and that is equal to a x plus h whole square minus a x square. So, this will be again, I can take the a common. So, this will be x square plus h square plus 2 x h minus x square. So, this will cancel out, and I will get a h square plus 2 x h. So, h is constant, it means this is a linear function. Now, if I apply one more time on this one, so what I will get? I will get a h square plus 2 x plus h into h minus h square plus 2 x h. I am just applying directly from here, and if you from here you can see that this will cancel out with this, and I will get a, and now I am applying my operator here. So, it will be a this one. Now, from here I will get this. So, yeah, so I will get 2 x h plus 2 h square minus 2 x h. So, this will cancel out, and it will be 2 a h square, and that is the constant value. Now, if I apply the third times this operator, its value will be 0. So, from here I can say that if my function is a second order, then I can apply my operator up to second order only. and that will be the constant value. If I apply the higher order operator more than 2, then all the value will be 0. So, based on this one I can say that from here I just make a conclusion that if I have a function f x that is the nth power, then if I apply forward operator on the function that is n times, then it will be equal to n factorial h raised to power n. That we can also verify from here, that whenever I have taken a x square, just a you take 1, so it is x square, so it will be 2 times, it will be 2 h square. So, it is 2 factorial h square. From here I can say that this is equal to, if I take a is equal to 1, then it will be 1 factorial into h. So, based on this one I can very easily show that this is equal to this, and this is a very important relation we are going to use for any polynomial of degree n. So, now from here I can say that, so using this one, when my function f x is a polynomial of degree n, that is my p n x is equal to a n x raised to power n, a n minus 1 x raised to power n minus 1, and so on, a 1 x plus x 0 or a 0. So, this is equal to a 0 such that a n is not equal to 0. Then now if I take the nth forward operator on this one, so in this case it will be equal to a n and factorial h raised to power n. So, that is the same way we are doing, only thing is that here we are getting the coefficient of x raised to power n as a n here also. So, that is the concept or the nth derivative of any polynomial is going to give us. Now, so we will use this concept later on to find out the interpolating polynomial. Now, we also know that also I have, suppose I have a del cube and I want to apply, suppose I take the value of the function at x 0, x 1, x 2, x 3 up to x n. So, all this value is given to me, and suppose I apply this one on any function. So, value is given to us. So, suppose I apply this value on some value. So, I have a value x 0, suppose this is my y 0, this is y 1, some value is giving here, it is y 2, like this one. So, suppose I apply this one on y 2. Now, in this case you can see that the value, the third forward operator is applied on a value of the function at the point x 2. It is not applying to a function that is like a polynomial we have discussed, that it is a polynomial of nth degree like this one or this one. I am applying this one only at the discrete value. Okay. So, in this case let us see what will happen. So, this is I want to apply. So, you can apply directly also, or maybe you can apply like this one, forward y 2. So, from here I will get forward y 2. So, y 2 I am applying here. So, this is my y 2. So, it will be forward. So, it will be y 3 minus y 2, because I am applying this on a given mesh point, that is given nodal value x 2 and has the value y 2. So, I am applying on this one, because we apply this one on a function, and in this case I have a difference value or the given value of the function in the form of discrete values. I have a x naught, y naught, x1, y1, x2, y2 like this one. So, this is up here. Now, again I apply the forward. So, it will apply forward y3 minus forward y2. So, this will be y4 minus y3 minus y4 minus y3, yeah, and y3 minus y2, and this one can be written as y4 minus 2 times y3 plus y2, and this one again I apply here. So, it will be forward operator applying on y4, y3, y2. So, this is y5 minus y4 minus 2 times y4 minus y3 plus y3 minus y2, and then from here I will get y5 minus, so y4 is here, 1 is here and 2 is here. So, it will be minus 3 y4. Now, from here I will get minus 2 plus 2. So, plus 3 y3 minus y2. So, now you can see from here that it is giving you the symmetric value like a binomial coefficient. So, 1 1 1 minus 1 and minus 3 3. So, that is the value if I apply third operator, forward operator on y2. So, if from here you can see that if I am applying the third operator on the y2, I am getting the value, the value y5 is involved, then y4 is also involved, y3 is involved. So, if I want to apply the third operator on y2, my forward operator will go 3 steps away from y2, that is up to y5. So, that is we have to keep in mind that which order we are able to apply or the forward difference operator on y2. Now, if I want to apply the same thing, I can do it directly also with the help of the relation. So, I wanted to find del 3 y3, del 3 y2. So, this one I want to apply del 3 y2. So, now I know that del is, I can write e minus 1 cube y2. So, that we already know that forward operator is equal to e minus 1. And now, from here I can take, that will be e cube minus 3 e square plus 3 e1 minus 1, and that is applying on the y2. So, this one I have just opened the cubic. So, this cube minus this times plus this. So, that will be the formula for this one. Now, if I can take this inside y2, so it will be e cube y2 minus 3 e square y2 plus 3 e1 y2 minus y2. Now, this is the shift operator 3 times. So, it will be, what is the meaning of this? E y2, that will be y3, because I know that E of fx, it is fx plus h, right. It means, and what is the y2? y2 means I am applying E on fx2, and fx2 is the y2, and from here I will get, this will be equal to x2 plus h, and x2 plus h is what? F at x3, and that is y3. So, I am shifting the one step. So, I am shifting here the 3 steps. So, from here I will get y5 minus 3 times 2 steps away from y2. So, it will be y4 plus 3 times 1 step from y2, that is y3 minus y2. So, if you see from here, I am getting this value and this value same. So, here I am applying this forward operator again and again 3 times, but here we are getting the values by the shift operator, by the relation. So, this is the way we can apply either the given operator directly, or we can use the relations between them. So, similarly I can apply various methods, like I want to find out del cube or del 4 on the given function when the data is given to me. So, maybe we can discuss this in the next lecture. So, we will stop here today. So, today we have discussed about some relationship between the operators, and then we have shown that how the operators can be applied to the given function. It may be a constant function, a linear function, or a nth degree polynomials, and from there we will take some help of these relations and we will define the interpolating polynomials in the coming lectures. So, thanks for watching this. Thanks very much.